Welcome to IT Pro TV. I'm your host, Don.
Coming at you live from San Francisco, California.
You're watching IT Pro TV.
Hello, and thank you for watching IT Pro TV, helping you learn wherever you go. I'm your host, Zach Memis, as we continue on with CompTIA A Plus 902. And with me is the expert on this subject who's bringing us all the information we need about troubleshooting today. And that's Wes Bryan. Wes, good morning, sir.
Hey, how you doing, Zach? It is
great.
great to be here. That's right. We're going to be looking at troubleshooting PC operating systems, and I have to tell you, they've kind of made my job a little difficult. And what I mean by that is, well, really, with when we talk about PC operating systems, a lot of times we're just talking about Microsoft's Windows, right? And I can tell you, it's getting harder and harder to create problems inside the Windows operating system so that we can demonstrate some of these issues. And the reason I say that is because the operating system does a very good job of really protecting itself. We have things like system file protection that has been inside of the operating system for a while, but things can still arise, right? Things can go a little haywire. A lot of times what happens is it's some kind of failure in the hardware. Could be malware, which really isn't the operating system's fault. Could just be like our browsing habits, if you will, or downloading email attachments. But we talk about troubleshooting PC operating systems. There are things that you can still run into. I mean, it's the reason you have computer repair companies out there, and we're going to try to dive into some of the, well, actually, we are going to dive into just about every single one of the objectives here, and we're going to try to demonstrate some of the scenarios that you might see when it comes to troubleshooting PC operating systems, right down from things like blue screens, from forcing a spontaneous reboot of the machine, to some other things that we might have to look at. So that's what we're going to be looking at today. We're going to be looking at troubleshooting the PC operating systems inside of primarily Windows today. If you are following along at home, let's go ahead. Some of these objectives we can't get in the title here because, again, they're quite long. So let's go ahead. We're looking at 4.1 today. This is given a scenario. Troubleshoot PC operating system problems with the appropriate tools. So we're going to see if we can try to break Windows. And like I said, it's getting more and more difficult to try to break Windows because it does a good job of maintaining its integrity, even surviving a reboot and a crash, and trying to keep its running, if you will, its life cycle going. But that's what we're going to be looking at inside of this episode.
Proprietary crash screens. Let's talk about that.
Proprietary crash screens, all right, this really comes down to what's known as a kernel panic, and every operating system has them, all right. Kernel panic is where basically it's down in the kernel level, and it's where a lot of times you'll get it when you have driver issues. Again, keep in mind that when we talk about driver issues, driver problems really a lot of times can be corrupted either because of a hard drive or because of a malware, if you will, and even the manufacturers. But when I say that, let me give you an instance where I keep kind of stressing this point that operating systems do a really good job, especially Windows, in maintaining its integrity. Right? Microsoft runs drivers through a very rigorous process. Actually, there's something out there called the Windows Hardware Quality Labs. And essentially what they do is, if a manufacturer wants to have their driver bundled into the Windows operating system and to be basically stamped with the Windows, let's say if you had a Windows 8.1 machine or a Windows 7 machine, and it says when you get a device, right, on the outside of the box, it's got a stamp that says Windows 7 ready, Windows 8.1, and I know by the time of this recording, and we'll probably see it in when the objectives update, Windows 10 ready, right? Well, for that to happen, for that piece of hardware to have that stamp on it, they have to submit their driver to Windows Hardware Quality Labs, and they go through a pretty rigorous process, testing the driver for its integrity, making sure that it doesn't cause kernel mode errors. These kernel mode errors, remember what happens in kernel mode. Kernel mode is a shared memory space, and this is where your drivers sit, your executive services sit, this is where the NTOSKRNL or the NT kernel sits, right? And they all share this memory space, which means if a driver corrupts, it can corrupt other data that's being shared and being utilized by all the other drivers, right? And that's where you usually get these blue screens, right? Proprietary screens. You'll see in here they talk about pinwheel. Pinwheel really isn't really a crash screen. A pinwheel, or not for PC at least. That's actually the pinwheel is something that you see inside of Mac. This little spinning wheel that locks up, and that does happen. But with Windows, like I said, with the drivers down there in the kernel mode, yes, they can cause blue screens, and that's a kernel panic, right? It usually happens through a general protection fault, and basically the CPU shuts itself down. What you have is what's known as a memory dump, and a memory dump essentially is Windows' way of just grabbing everything that was in RAM at that time and dumping it into a file, and then that file, a .dmp file, essentially can be analyzed by an engineer. It's not really for the average tech. I can't read a dump file to save my life, right? It's a lot of garbled, not garbage, but a lot of garbled output, if you will. And you can do debugging with it, right? Now, I say that it's not for the average tech. Let me go ahead and just throw like a parenthesis statement in here. Microsoft released what's known as the MDOP, right? That's the Microsoft Desktop Optimization Pack. It is amazing, and it's got inside of it something known as DART, the Diagnostic and Recovery Toolkit. And inside of that, you can create a DART recovery pre-installation environment disk in which you can use something known as the crash analyzer. And the crash analyzer is worth its weight in gold because you got to go through a couple of processes. You download the software development toolkit, and inside of that they have the debugging tools, and you bundle that together with the crash analyzer, and it can take those dump files that traditionally haven't meant anything to a tech, again, the average tech outside of like an architect or engineer, and it can grab that dump file, it can analyze it for you, and it can tell you what the application, the driver, or the device was that actually caused the problem, right? Cool. That caused the blue screen. All right, now let's go ahead and let's see if we can't create a blue screen right here so you guys can see what the proprietary screen is. In fact, I got a Windows 7 or a Windows 8.1 machine, excuse me, and SysInternals. This is another company that it's actually owned by Microsoft. Originally, it wasn't owned by Microsoft, but they've got just a great suite of utilities that Microsoft bought them, and they're like, hey, you need to come work for us. So if you get a chance, this is called It's Not My Fault. So understand that I'm going to create a blue screen here so that we can demonstrate the scenario that you might see on the exam, but understand that this application is creating, if you will, the blue screen, if you will, or the crash, right? Now, I say that we're going to see the crash screen. It's also called a BSOD, the blue screen of death, if you will, and again, it's kernel panic. All operating systems have these. It just depends if it's proprietary on how they display it to you when it happens. Let me show you what I mean. So if I launch up my It's Not My Fault, or I always say It's Not My Fault. It's called Not My Fault.
Not My Fault.
There are a couple of different types of blue screens that we can create. Notice they have a kernel mode and they have a user mode. Sometimes the user mode, what's going to end up happening is it just kind of wigs out the screen. Maybe your desktop DWM, your Windows Desktop Manager, kind of resets itself and it brings your desktop back. And again, this is Windows' way of correcting itself. They've taken a lot of the functionality and they put it in user mode because it just affects the user and the user profile, but not the kernel mode, which could corrupt drivers in the system as well. What we're going to do is we're going to create a kernel panic or a crash screen, if you will, that's down there in the kernel mode here. And let's see what it looks like. We're going to go ahead and crash it. There we go. So notice what's happening here. You'll find this, and sometimes this information doesn't look like it really gives us really any information, but I really like this because what they're telling you here is driver, and I know that kind of happened kind of fast, but it said driver not equal to or less than. It gives you a little bit of information. It used to show you in the earlier days, like Windows 7 and prior, it would show you memory locations. And it would basically be a memory address. That IRQ is what's known as an interrupt request line. Understand going way back in the earlier days, prior to things like plug and play, well, and also something known as ACPI, the Advanced Configuration Power Interface, we would have to manually configure interrupt request lines. And that's because when you think about a CPU has to be interrupted so that a device can communicate with it and we can use our devices, because the CPU is just so fast that everything else is just hundreds and thousands of times slower, millions of times slower than it. So what you would have to do is you would have to set up the resources and you would have to manually say, okay, you're going to interrupt the CPU through this line, this IRQ, you set this IRQ to this device, your system clock uses this IRQ. Well, today, we don't need to worry about that. Windows, and I'll actually show you where you can see this, Windows in the background manages that for us. However, understand that only one device typically can use an IRQ, and what happens is when you've got two signals that are sent to over the same IRQ, they cause a conflict. All right, a lot of times that can be a driver issue. It looks like I got a Windows update running here in the background. Hopefully it doesn't take too long, and hopefully it doesn't cause a crash right here on the screen. But we do while this is running. So the IRQ, what that's letting me know is that we had a conflict. All right, now this application basically stole an IRQ that was already being utilized by the operating system for another procedure or process, and because of that conflict, the application caused the reboot. We'll see that here in a second. All right, so we see that the computer has rebooted here, so we can log back in. And one of the things that is interesting that we can do is we can actually see, you know, the results of a kernel panic inside of a utility inside of Windows that's actually called out here within all of these different utilities that we have, or tools within the objectives. They call out what's known as Event Viewer. Let me show you what I mean here. If I right-click on the Windows charm here, you'll notice that third down from the top we have Event Viewer. I also want you guys and gals out there to keep in mind that this is in computer management. So if I launch computer management, we have Event Viewer in the list here too. So a couple different ways that you can find it. A lot of times I like using the computer management because it's kind of like your convenience store for different system utilities. It's a one-stop shop and you get everything bundled in. But I'm going to go ahead and just for a little bit more real estate on this, I'm going to just use the Event Viewer MMC. Again, it gives us a little bit more real estate here. So what I'm looking for is the Windows logs, right? And we've talked about in other episodes, we've talked pretty extensively about this utility, kind of showed you how to use it. So go back to those features and those administrative tools. Definitely want you to be aware of this. So the log that I'm looking for is the system log, right? And when I choose the system log, one of the things that you might notice is that, and let me see here, if I'm going to filter the log. So over here on the actions pane on the right hand side, I'm going to choose filter log, and I'm going to do critical error and warning, and I'm going to choose OK. And I should see in here somewhere there should be a, let's find out here, let's see if we can find it. And if not, I don't have a critical. Oh, there's a critical. There we go. That's what I'm looking for. All right, and if I look, notice that I have this kernel power failure, right? This is one of the things that it tells me. Notice it says the system is rebooted without cleanly shutting down first. This error could be caused if the system stopped responding. This could be a PC lockup, crashed or lost power. In this case, it is a crash, right? It crashed the system, right? And we can see that this is a critical level error, all right? So understand that this is one of the ways that you can diagnose when one of these problems happens. Now, I believe we should see, because of the fact that this was an application that caused the problem, clicked so fast there, we should be able to see this, if I remember right, in application too. Let me just check. I can't remember off the top of my head if it'll also log one in application. I'm pretty sure it should. Let's see here. That's license activation. Oops. No, I'm not really seeing anything in here. Nope. These are old. No, so I'm not really getting anything here. Open procedure. Okay, so no, I'm not actually seeing that in there, but I could see that it was inside of the system logs, and it's let me know that there was some kind of problem here. And we need to kind of investigate and see what's going on. So keep in mind that you can have those situations in which you don't get the ability, if you will, to actually see what the information was on the screen. Sometimes you can pause that. Let me show you where you can do that. One of the things that I like to do as a tech, if we go back to our desktop, we right-click on our Windows tile here, and I go to System this time. There's a couple other things that you can do, and this is one of the things that I kind of like to do with some of the machines that I support, just because if there is a blue screen, I want to know about it. Notice how it rebooted automatically, and I couldn't tell what was going on. I couldn't get any information, right? Well, you can actually change that. If I go into Advanced System Settings right here, and notice that we have this Advanced tab, and we have Startup and Recovery. This is kind of important for me. Notice that I have the Settings button. If I choose the Settings button, by default, you'll notice that it says automatically restart the machine. I usually clear that, all right? Notice that I took the check mark out of the box there, and I choose OK. and I'll choose OK again. Now watch what happens this time. I'm going to go ahead and rerun this. We're going to cause another memory dump. We're going to see if we can break Windows here. This is supposed to happen. I've tried very hard. You guys out there at Microsoft, you're making it very hard for me to do my job. I'm trying to break this operating system, and it just keeps coming back to life. But let's go ahead. We're going to run Not My Fault one more time. Again, from sysinternals, we got to give Mark out there credit there. Absolutely great program here, and you can see why we're using it. Zach, you had asked a great question in the break in between episodes here. Said, hey, why would you use something like that? Well, exactly, training. Yep. You know. So let's go ahead and crash. We crash the system here. Notice that it is doing a memory dump. All right. Notice that it says driver IRQ not less than or equal to, and it's telling me what the system file is here, and that's important for me. All right. Now, notice here too what's going on. Notice that it's 100% complete. So what's going on, right? We're just collecting some error info, and then you can restart. It takes that information that's in RAM at the time and it dumps it right into a file. And again, traditionally, you're supposed to be able to take these dump files. You can hand them over to some kind of tech. They have the diagnostic and recovery toolkit in which you can actually put these inside of the crash analyzer. Well, if you don't see this information, you're not going to know what's going on. And this is a great way to kind of actually find out what's going on here. Notice it tells me inside of this information, hey, there's a driver issue of some sort. And the IRQ not less than or equal to, again, different IRQs that we have, and this is the system file that's actually causing the problem. And you can see it says myfault.sys. This is supposed to happen, right? It's happening on purpose, right? Well, I'm generating this. But this is what you would see in a situation where maybe you did download a driver, right? You downloaded the driver, you installed the driver, and it causes an issue. Well, that could be a problem, right? That causes a problem because if that driver becomes problematic and it does cause a blue screen, I don't know what the driver issue might be. This gives me the ability to see that. Now, this is also an improper shutdown as well. I want you to keep that in mind too. The other improper shutdowns that you have a couple different types of shutdowns. You have what's known as a hard boot and what's known as a soft boot. All right, let me show you what a hard boot is, okay? A hard boot would be like me pushing the power on the machine. In fact, I'm going to virtualize this here in the virtual machine. But if I reached over and I pressed power and I held it on the power button on the physical machine, right? That's what's known as a hard boot, all right? And I'm going to try and do that right here. We'll do it. We'll see if it does the restart. All right, so that's called a hard boot. All right, a soft boot is a little bit different. A soft boot is where you do a graceful shutdown, right? And a soft boot is where you're going to actually, you're going to restart the machine. It's called a graceful shutdown or a graceful restart. And that's one where I actually would, and here, let me show you guys. My head's kind of covering it up here. But if I was to restart the machine here by choosing restart, right, that's a soft reboot. It's different. Hard reboot is, I think of a hardware reboot. That's how I remember it on the exam, versus a soft reboot, software reboot. So do keep that in mind. So we can see that information right there too. Now, there are times when you might have overheating issues. So for instance, CPUs, and again, notice what we're talking about here. This machine is recovering. All right, I'm creating blue screens. I'm creating kernel mode blue screens, and Windows keeps coming back. All right, it's kind of like a Rocky fight, right? You get knocked down and it's back up, and it's saying, "Hey, we're back here to go again," right? So we're gonna throw some stuff at it. I'm not gonna be biased in any way. I'm gonna hit it pretty hard when it comes to this machine.
It takes a licking and keeps on ticking.
It absolutely does, Zach. So let me show you a couple other things that we can also do. Sometimes what you might have is a failure to boot. And, well, failure to boot can be a couple of different reasons, all right? A failure to boot might be because you have an improper boot sequence set in your operating, not in your operating system, but in the BIOS itself. That does sometimes happen. And one of the ways you can typically see that is when you boot into, you can see it a couple of different ways, right? We can boot into BIOS, and what we can see is that maybe we have the optical disk. The optical drive is actually populated, and it's populated with a disk that really isn't supposed to be bootable at all. Could be a software disk. The other thing that this might cause this is when you have, for instance, a USB device that's bootable, that's actually plugged into the USB port. When that ends up happening, that could be a problem as well. That could be the fact that it's trying to boot to that USB device, and what ends up happening is, again, let's go ahead, and I've tried to create this problem here. If we could show my screen, notice what's happening here. All right, you might get a failure to boot as well, and it might actually boot right into recovery. I've actually, let's see if it's actually going to go into its automatic repair. Yep, there we go. So this might be something that ends up happening as well. Let me see if I can pause that. All right. So here is something that can happen. All right, spontaneous shutdowns and reboots. You could see that a PC, its CPU is overheating. You're having an overheating issue. It could be a failure to boot, in the fact that, notice it says it looks like Windows didn't load correctly. What you couldn't see in the background there, I didn't want to waste your time, is I was constantly doing a spontaneous reboot of this machine. This actually happens when CPUs overheat, or the system, the internal temperature of the system starts to heat up. What happens is your CPUs have these thermal temperature sensors. An internal thermal temperature sensor will trigger, and it will shut the whole machine down. And it's your CPU's way of protecting itself. Now, if it happens too many times, why did the machine fail to load? Why did Windows not load? Well, again, that's an improper, a failure to boot. A couple of things could happen. Like I said, going back to the first thing, a failure to boot could be the fact that you have a non-boot device plugged into a USB port, and you have pointed your boot sequence in BIOS to that location. If you get multiple of these spontaneous restarts or shutdowns, what's going on? If we go back to my screen here, notice it says if you'd like to restart and try again, just click Restart My PC. Otherwise, choose the Advanced Repair option. Notice it says it looks like Windows didn't load correctly. Okay, so what's loading here? All right, so let me tell you a little bit about the boot process. When Windows goes to load, you have what's known as a boot manager, and you have what's known as an operating system loader. All right, with the boot loader, or a boot manager, excuse me, and an operating system loader. All right, the boot manager, bootmgr.exe. All right, it looks and it says, what operating system am I going to load? All right, now, if it finds a non-Windows-based operating system, it loads a very generic DOS-based bootloader, and it lets the other operating system take over the PC. It happens in multi-boot. However, the other thing that it can do is it can also look for other Windows operating system loaders. If it's the earlier loaders, like XP, it's going to be looking for NTLDR, right? That was the XP. Prior to Vista, they had a different architecture, and it would use NTLDR. Now, if that's missing, you can get a missing NTLDR, then what you would have to do is you'd have to boot into a recovery environment, you'd have to repair, or a repair disk, and you would have to repair your operating system. Since Vista and all the way up to Windows 10 today, and including Windows 8.1, what the boot manager is looking for is something known as winload.exe. Winload.exe is actually the Windows operating system loader of today, and Vista and on, really. All right, now when that file gets corrupted, it doesn't load the operating system. It's also looking for another file called NTOSKRNL. Well, what is that? That's the Windows kernel. All right, so see what's going on? We have a chain of events going on. We have the boot manager that is looking for winload.exe, which is the operating system loader. And the operating system loader starts the files, it starts the system files, loads system drivers, and then looks for the kernel and loads the kernel into RAM. Okay? Now, why did that screen that we showed you, why did it load? If it didn't find the operating system, what the heck are we seeing there? Well, understand that every time your computer boots, all right, when your computer boots, it sets a little flag to automatically fail over to recovery. All right, it's called automatic recovery failover, all right? And it sets a little flag, and it lets the boot MGR know, don't load WinLoad. Don't load the operating system loader. Something went wrong. Load the recovery environment. Load the pre-installation environment so that you can fix it if you need to. Now, this happens every time you boot your machine, every time, whether something's wrong or not. As it goes through the boot process, if it finds that there's nothing wrong, it loads WinLoad. It still has that flag set, though. Keep in mind that recovery environment flag is set. WinLoad loads, starts the file system, initializes the file system, starts the system drivers, and then goes to the NTOSKRNL and loads the kernel, and the kernel starts to come online in Bootstrap. Then you're presented with a logon screen. When you log on to your machine, the bootloader, boot MGR, removes the recovery flag, removes it. So I want you to understand that the boot process is never fully finished until you successfully log on to the machine. Now, why is that beneficial? Well, imagine us going to this boot process and we spontaneously keeps restarting. Something's wrong. I've never got to log in. So at a certain point, the boot manager notices that and automatically loads the recovery environment, and that's what we're seeing here.
It's a fail-safe, right?
It is a fail-safe. That's exactly what it is. So again, as a real quick recap, boot process starts, set the recovery environment, set that pre-installation environment so we can go into a system recovery option. Once you normally boot the operating system and you log into it, system is just fine. Boot process has finished successfully. We have successfully booted the operating system. The recovery flag is removed. Now, when you restart your computer, same thing happens again. Set the recovery flag. If you end up booting into the machine, everything's fine. All right? So that's a little bit drawn out there, but that's essentially what's happening. Now, it's more in-depth than that, and we could talk about some other files that are down in there, like the hyperfill.sys file, but that should be enough for the exam, knowing that you have the boot MGR, all right, .exe, that's the Windows Boot Manager, knowing that you have winload.exe in the earlier days, and it's still in the exam objectives, and I kind of disagree with this one because XP is not an operating system that you're required to know for this exam, but they do say missing NTLDR. That's XP's bootloader. You don't find that in Windows Vista or any of the operating systems after that. It's winload.exe. So I do want you to know that. And I do want you to know why we're seeing this recovery environment, right? Because if something goes wrong, if I get these spontaneous restarts, I need a way that I can get into this operating system and try to fix it. All right? Now, let's go ahead, and I know we're coming up short on time here, Zach, so let me go ahead real quick.
As usual, you're doing a wonderful job because no stone unturned. Thank you.
Absolutely. So I tell you what we're going to do. Let's go ahead. We're going to leave you with a cliffhanger. We're going to leave you right here at this recovery environment. In fact, if we could show that, thank you out there to our director, if we could show you that just one more time. We're going to go a little bit farther, and we're going to show you some of the advanced repair options if you do come across some of these spontaneous boots, if you will, improper shutdowns, failure to boot, proprietary crash crash screens, and you might have to fix your operating system. But it looks like you're going to have to come back in a part 2, and we might have to put a comma in this one.
Wow, troubleshooting PC operating systems, and that's CompTIA A plus 902. Lots of wonderful videos in this series. Make sure you watch all of them. You'll be very glad you did. Wes, wonderful job as usual. And thank you for watching IT Pro TV. You know, a good IT pro is always learning. I'm Zach Memeth.
And I'm Wes Bryan.
And we will see you very soon.
Thank you for watching IT Pro TV.